Okay. So hello students, I think there has been little confusion in understanding this particular problem. So the problem says expand log of 1 plus cos x by using MacLaurin's series up to the term containing x to the power 4. Now, if you remember what MacLaurin series is, it says that the first term in the MacLaurin series expression is going to be y0, right? And y is basically like log of 1 plus cos x or whatever the given function is, and that should be added with x divided by 1 factorial of the first derivative of y at 0 plus x square divided by 2 factorial multiplied by y2 0. Y2 0 is the value of the second derivative of y at 0, and then plus x cubed by 3 factorial times y30. Y30 is again the value of the third derivative of y at x is equal to 0 plus x to the power 4 by 4 factorial multiplied by y40, and y40 is again the fourth derivative of y, the value of the fourth derivative y when x is equal to 0, right, and plus so on. So what we need to do here is we just need to look at these terms up to the x to the power 4 term, right? So what do we need? We need to find out what y0 is, we need to find out what y1 is, y2 is, y3 is, y4 is, right? Okay, so let's get into the problem. So in this problem, yx is equal to log of 1 plus cos x, right? Okay, then in order to find out y1, we differentiate y1 with log of 1 plus cos x with respect to x. There's this chain rule that is being used, right? And we get minus sin x divided by 1 plus cos x. And then, sin x is 2 times sin x by 2 cos x by 2. 1 plus cos x is 2 twice of cos squared x by 2, and we get negative tan x by 2, right? Now, when we look at the second derivative, it's basically the derivative, the differentiation of the first derivative, right? It's equal to d dx of negative of tan x by 2. Again, here, we use the chain rule. X by 2 is the new variable, and then x is a variable, the original variable. So we get negative half secant square x by 2. Okay. Y3 is nothing but again, the derivation of y2 with respect to x, right? And here y2x is from the previous step, we get that as negative half secant squared x by 2, right? And here again, there is we use a chain rule. There is the variable secant x by 2, secant square x by 2, and x by 2 is a new variable, secant x by 2 is differentiated, and then we differentiate x by 2 with respect to x, and what we get is negative half secant square x by 2 tan x by 2. Okay, now y4 is the differentiation of y3 with respect to x, and here we take the minus, we take my negative half secant square x by 2 tan x by 2 from y3, and we use a product rule. We keep secant square x by 2 and as it is, and differentiate tan x by 2. Then we use the plus symbol between that, and the other term being tan x by 2 kept as it is, and the differentiation of secant square x by 2. And you see that we use the chain rule multiple times, right? And we differentiate this, and the final answer is final expression for the fourth derivative of x, fourth derivative of y with respect to x is minus 1 by 4 secant to the power 4 x by 2 minus half times tan x by 2 secant cube x by 2. Okay, now having done that, we have to now find out what y0, y1, y3, and y4 is, right? So y0 is log of 1 plus cos 0, in place of x we have put 0, that is equal to log 2. Negative tan x by 2 is y by y1, the expression of y1, and then we put x is equal to 0 over here, and we get 0, right? y2 is minus half secant square x by 2, right? But here we put x is equal to 0, and then we get minus half over here. Similarly, when you look at y3 and y4, y3 is minus half secant square x by 2 tan x by 2. We put x is equal to 0, x is equal to 0 whenever we find x, and when we find out the expression value, it becomes 0. Finally, y4 is 1 by minus 1 by 4 sec to the power 4 0 by sorry x by 2, and minus half times tan x by 2 secant cube x by 2. So what we put is that we put x is equal to 0 wherever there is x, right? And then simplifying the expression, we get the value of minus 1 by 4. Now, in the MacLaurin series, as we had seen previously, fx would be equal to y0 plus x divided by 1 factorial y1 0, x squared divided by 2 factorial y2 0, plus x cube by 3 factorial y3 0, plus x to the power 4 by 4 factorial y4 0. Y0 is 2, y10 is 0, y20 is negative half, y30 is 0, y40 is negative 1 by 4, right? So we substitute all these values over here, and simplifying gives us like log 2 plus 0 minus x to the 4 plus 0 minus x to the 4 by 96. And hence the MacLaurin series expansion of the given expression is equal to nothing but log 2, right? Log 2 minus x to x square by 4 minus x to the power 4 by 96. Hence that is the answer, guys. Okay, thanks for watching.